And welcome to part 2 in our unit on software engineering. Last week we talked about the software life cycle and the different ways to put together software. This week we're talking about the nuts and bolts of actually engineering a piece of software. And today's lesson is titled Teamwork Makes the Dream Work. No truer words have ever been said, especially when it comes to software engineering, because software engineering is the field in the world that is the most collaborative and the most teamwork oriented. My friends in the software engineering industry tell me that they can teach people how to code and they can teach people about computers. They cannot teach people how to solve problems and how to be a good teammate. If you know how to solve problems and be a good teammate, then you will go far in this field and make scores of money and win lots of awards and all that stuff, because teamwork makes the dream work. So with that said, let me introduce you to the team that usually puts together a piece of software. It's important to note before we get to that point that not every software engineering company has every single person represented that I'm going to give you. And obviously a lot of software engineering companies have multiple projects going on at the same time, multiple teams working on multiple projects, but this is your ideal software engineering team. So first up, we have the project manager. This is the person who is the boss. It is their job to set deadlines. It is their job to get regular reports from the rest of the team. It is their job to make sure that the project and the software is being completed. It's their job to report to all members of the team and organize them. Here's what's interesting about the project manager. This person does not have to be a computer programmer. They have to know a little bit about computer programming, but they actually don't have to know a lot about it. They do not have to know a lot about systems and about how people work together well and about what people want and how people think. And they have to know when everybody's birthdays are so that they can give someone a birthday present. And they have to know what their kids' names are. And so the project manager is a very relational human being, and that is what is looked for in that person. So if some of you have struggled with this class, with the nuts and bolts of database design and hardware and network and all that and programming, don't fear, you can still make a lot of money. In fact, I right now, knowing just enough to teach computer coding, but not enough to actually, make a computer program by myself, I could still make about $60,000 to $70,000 a year being the project manager of a team, because I have degrees in humanities and degrees in philosophy and all of that. And so the project manager is a very important part of the team. The next team member we have is your database creator. This is the person whose job it is just to keep track of all the data. So think about our unit on database design. This is the person who's good at that, who enjoys doing that, who enjoys making these large libraries full of information and coding all that in. They are not necessarily a computer programmer. They are a design or a database designer, very different than a computer programmer. These guys are the ones making tables and charts, working with Microsoft Excel and Google Sheets and other database type software like Microsoft Access to make sure all the information that everybody else needs is kept securely in one place and can be easily found. This is your person who does a lot of queries using SQL and all of that. Then, of course, in the middle, you have your developers and your programmers. These are the people who are good at computer programming, who do know something about networking, who are very skilled in that, and are good at actually putting the tires to the pavement by metaphor. They're the ones who take all the ideas and actually make them work on a computer screen, make a usable program. So it shouldn't surprise you that they're on our team. The next person we have on our team is your tester. These are the cool internet kids whom you contact and you say, hey, you want to run through our program about 400 million times and see what errors you find and report them back to us? And so they're the ones with the glasses, the ones who enjoy finding the faults in everything, the ones who enjoy ripping your program apart and saying, I found this and I found that. Usually your testers need to think outside the box. That's a very important quality for them to have. They think to type something into your program that nobody else would ever think to type into your programmer because they're looking for a fault. They're looking for a flaw. These people are annoying, but they're so super helpful because they will find the breaks in your program before everybody else will. Then the last member of our team, this one might surprise you a little bit, is your end user. This is the guy who maybe doesn't even know how to use a computer, whom you want to sell your program to. This is the person paying you money to use your program. This is the person who's going to be playing your video games. This is the person who is going to be bragging about your program to their friends and saying, I don't really like computers, but hey, this program's really easy to use. So they are part of your team. It's important for you to know, I'm going to emphasize this over and over again in this lesson, they are part of your team. You need to treat them as a teammate. I said earlier, the project manager needs to know when everybody's birthdays are. That is 10 times more true for the end user. You need to know everything about them. And so your end user is incredibly important. In fact, I'm going to stop right here. I want you to look at all 5 of these people. And I want you to ask yourself, which one of these is the most important? If you said the end user, you are right. The end user is the most important person on your team because they are the ones giving you money to actually make your program. They are the ones feeding your family and buying your video games and paying for your utilities. So you want to make the end user happy. They are very, very important. So with that said, what usually happens in the software world is that an end user will approach a development team and say, hey, I want you to make me a program that does blank. Sometimes the end user is a whole company of people. Sometimes the end user is a particular person. Sometimes your end user is just a teenager online on Twitch saying, wouldn't it be cool if there's a video game that? And you're like, hey, I could make that video game. And so they will come to you and they will ask you to make this program. The next thing you do is you put together what is called a design document. If you guys take my video game class, my Introduction to Interactive Entertainment, CS 1010, it is all about the design document. In fact, the main project for that class is creating a design document for a game that you want to see made. And I really like that class because it's taking this lecture and stretching it into 16 weeks so that we can actually very slowly take you from beginning to end of a design process. So before you start coding, before you start making something, most companies put together a design document that basically details, here's how we're going to make this program. Here's how we're going to make the software. So the design document happens in 7 or 8 very easy steps. The first step is you need to learn the current system. Now, every single computer program does something that a computer program did not do before computer programs were created. So even think about your video games. Video games are not new. People have been playing board games for thousands of years. And so when you go to create a video game, you even something like that, you need to learn the current games. Like the very early designers of video games needed to learn how current board games worked. In fact, the board game that invented the video game genre is Dungeons and Dragons. Almost every single video game you can play goes back to Dungeons and Dragons. So somebody had to learn Dungeons and Dragons before they could design a video game. So you need to learn the current system. So if an end user is a person or a company that says, you know, we've been doing this thing by hand, we've been taking all these notes by hand, and we would really like a piece of software that took all of our notes and turned them into types of things that we could search, you need to learn their current note-taking system. You need to learn who's taking notes. You need to learn what notes are important. If someone comes to you and they're the person at a warehouse and they've been doing all the payroll by hand, then you need to learn how they've been doing payroll. You need to learn payroll systems so you can write a program that can do their payroll for them. Think about RenWeb. Before the school used RenWeb, all the teachers used paper and pens, and there were other systems of ways of reporting attendance and reporting grades to the principal and to the parents and to the students. So the makers of RenWeb and Canvas and Moodle and all the other online learning management softwares, they had to sit in the schools for hours on end. They had to interview the teachers and the principals and say, how do you do this? So that's step 1, learn the current system. Step 2 then is create what's called a UML. if we were in class together, I would have a lot more time to go over this with you, and it's kind of a bummer, but it's just good right now for you guys to know that it exists. A UML is a Unified Modeling Language. The UML is your way of working out with your team, including the end user, how you are going to represent things and write things to each other. I don't know if you guys know this yet. You may be a little bit too young. But every single company has its own language, has its own acronyms, has its own sayings, has its own things, ways of doing things. And so you want to sit down with your team and you need to design a bunch of diagrams and say, here's what our diagrams are going to mean. If it's a square, it's going to mean this. If it's a circle, it's going to mean this other thing. We're going to call the end user the EU. So write that down. So you're going to create a vast unified modeling language. The good news is, now that we've been designing software for 10, 20, 30, 40 years, there are plenty of UMLs out there that your team can just agree to adopt and say, we're just going to use this one. Microsoft has one that they've made public that anybody can use. I think Google has one they've made public. If you guys want to, you could go ahead and search those up and kind of look at them. But you need to agree with your team and write it down in your design document. This is what all this stuff means. This is what this diagram means. When we use this abbreviation, this is what it means. When we use a square, this is what it means. So that everybody's on the same page and nobody's talking over and against each other. Step 3 then is you create a data dictionary. So this goes back to your database. And if you guys think about the steps of making a database, this design document's very similar. You write down all the information and you define it. So picture a dictionary. In a dictionary, you have a word and a definition. That's what a data dictionary is. You just write down this, and this is what it means, and this is what it means. And all of that is later going to be turned into computer coding. Computer coding creates you need a lot of data, you need a lot of databases. So you create your data dictionary and you define everything for the computer program. Step 4 then is you design reports. This means that you draw out how you want information to be output to the user. So the user is going to need a report. Remember, the basic definition of a computer is it's something a user can put information into that will process and remember that information and put that information back out to the user. Next week, we're going to talk a lot more about step 4 when we talk about user interfaces, but you need to actually draw out on a paper, this is what all these reports are going to look like. This is how to interpret them. This is what they're going to say. So moving on, step 5 is then you structure the logic flow of your program. This is your conditional branching. This leads to this, leads to this, leads to this. If this, then this, and if not this, then this, and all that. So you structure your logic flow. You define your variables. You write your conditional branches, and all of that stuff. This is how the program, this is how one screen is going to lead to another screen, and this is how it's all going to be mapped out. Then step 6 is you build a prototype. So you put together a very quick, fast, sort of rough draft of your program. And then step 7, you put all the pieces of your design document together and create one cohesive document that then you can program and turn into the actual product that you are willing to sell. So step 7, you just copy and paste everything into one design document, give it a version number, and then you tell your team, this is the document that's going to help us design the program we're going to design. And then step 8 is consult the end user. Did you guys catch that? I just lied to you. See, this was a trick. Step 8 is actually make the program while you consult the end user at every stage. Do not wait to consult the end user. Consult them at every single stage, every single step of the design document. You should be working with your end user. You should be asking them, does this logic flow make sense to you? If I give you this report, are you able to tell me what this report means? Are you able to use this prototype? What about this prototype are you not able to use? We defined this word that you used as this. Was that actually a true definition of this word? You need to be consulting the end user at every stage of your program. The end user is an important part of your team. In fact, when I was taking this class last summer, my professor said that you should actually get their initials and signature on everything. I have a feeling he's been burned by an end user before. He's created a program and brought it to the end user, and the end user said something like, this isn't what I asked for, this isn't what I agreed to. And he learned, even though the end user had agreed to it, he learned, get their signature on everything so you can pull it out. And if they complain, you can say, you signed off on it, you said that this thing was okay with you. And so get the end user signature on every single part of your design document. As you're actually making the program, get them to sign off on everything. Save every email, because if they're paying you money and they don't like the end result, they're going to sue you. And you're going to have to give all that money back, and then maybe even some, unless you can prove that they signed off on everything. So make sure the end user is consulted at every single stage of the process. Make sure that what you are making is good for them. If you're making it for a more generic public audience, release test versions, release beta tests, get their feedback, show your prototypes on Reddit and stuff. That stuff helps a ton. It gets feedback. Don't be afraid of them. So that's your design document. That's how to go about sort of putting together a plan for making the program. Then the last thing we need to talk about is not falling on your face, like this guy, this stick figure down here is about to do. Don't fall on your face, or avoiding the pitfalls. When software companies are doing any sort of project, there are three major mistakes that they make, and all of them are costly. The first I've already talked about, user phobia, being afraid of the user. Users are mean, sometimes they're overly critical, they're really frustrating sometimes, but once again, they're the ones giving you money to feed your family and pay your utilities and your rent and go see movies and stuff. So you should probably not be too afraid of them. You should probably cozy up to them. You should probably know when their birthday is, when their kids' birthdays are, and you should probably know what their wife or their husband's name is. You should probably know where they grew up. And so don't be afraid of them. They're scary. I'll give you that. It's scary, right? But don't be afraid of them. Step 2 then, pitfall 2, is signing off to too much work. This kind of goes back to user phobia. If the user is asking you to do too much, you have to be willing to walk away. You have to be willing to say to the user, we can't do this much work in this much time. This is over our heads. This isn't something we're going to do. Guys, it's much easier to say no at the beginning than at the end. If you say no at the beginning, no harm, no foul. The user can go find another company who can do it, or they can try and find out that their expectations were unrealistic to begin with. Then that's fine. If you say no at the very end of the process, after they've already given you money and after you've already spent hours and hours with them, that's a much harder conversation. So don't sign off on more work than you can handle. If you can't do it, just say no. Just say, sorry, I can't do this right now. There's no way. Go find someone else. And then the last pitfall is a big one. It's called scope creep. Scope creep is what happens when you are working on a program that does the payroll for a carpet company, and somebody in your business says, oh, you know what? I was just in a meeting with the user, and they said it'd be helpful to have a program that kept track of their customers too. Do you think we could do that? And you're like, yeah, we could probably do that. Make it just fold it into the same program, do payroll, and then keep track of customers. And then somebody else says, yeah, well, while we're doing that, we could probably do billing for them too. And you say, okay, yeah, we could probably do billing for them too. And then you said, oh, while we can do that, their calendar system's a little bit weird, and they're using a weird thing for that. Why don't we program a calendar in for them? So you'd agree to do a calendar for them, and now you're at pitfall 2, right? Now too much work. Scope creep happens all the time, and it will ruin a software. And so if you said yes to one thing, try to keep the yes at that one thing. Try not to fold too much into it. Guys, I'm designing my own video game right now, and I have had to fight scope creep at every section of the game. You want to know why? Because I keep playing other games, and I thought, this is a really cool mechanic. I should put this in my game. This is a really cool character. I should add a character like this in my game. This is a really neat map. I should add a map like this in my game, right? And now I'm making like the video game to end all video games, and I'm just an amateur programmer. And so just be careful of scope creep. Just be willing to say to your employees, yes, that would be a great idea. No, we're not going to do it right now because it'd be too much work. So pitfall 1 is saying no to the user. Pitfall 2, is saying no to the user. Pitfall 3 is saying no to your employees and the other people on your team. Being willing to say, good idea, but we agreed to do this other thing right now. So I know that's a lot of information for you guys, but that's the actual nuts and bolts of putting a piece of software together, a little bit about design document, your program team, and some pitfalls. I look forward to reading your comments on the lms.renweb.com. Have a good one.